Okay, the circuit episode 8, I think it is, Jay. We're on
Yeah,
episode 8. How about that?
pretty cool. Lucky number 8.
Lucky number 8. So today's discussion will be interesting. What we talked about and kind of the way I think about this, so the topic for everybody, spoiler, is AI infrastructure. And the way that I think about this is there's some fundamental compute problems and bottlenecks that we're up against with generative AI, large foundational models. And there was some news around that today from Facebook with their llama models, which are smaller, obviously not quite as robust as something like ChatGPT that was on something like 300 billion parameters. And these things are just going to get bigger as larger foundational models go. But the reality of this is there's a tremendous, and I don't think everybody fully understands, just a tremendous amount of compute that goes into this. In fact, I saw a tweet a couple days ago where there was some power dynamics, so energy usage to train these models. And it was like worse than crypto, like in terms of how much energy it takes to run 10, 15, however many thousand GPUs we're running to train these models. But that's the stage that we're in is the last few years have had these transformer architecture models kind of breakthroughs now start to move, and you're seeing with ChatGPT and Google's Bard and a range of other things that are going to show up. And when I look at this, I'm astounded at how computationally intense it is, but then also how fast this overall market's growing. And I feel like we're going to run up against a demand for AI applications outstripping our ability to provide necessary compute and to some degree necessary scale to meet that demand. So I'm just lob my big problem out at you, and then there's my grand initial problem statement.
Okay. I
Okay.
think, yes, I certainly agree. There is big demand for AI systems. Obviously, everyone's talking about it. I live, half a mile from Hayes Valley, which is apparently the epicenter of all things
Mm-hmm.
GPT.
Mm-hmm.
I tend to discount a lot of what we hear, though, because we're just at that point in the hype cycle where
Yeah.
GPT is going to take over the world. I think we've done this so many times. You and I both know, like it's going to take a long time to get there, but it's going to be probably bigger than we expect when it does. Just to put some things in context, I looked this up, and by look it up, I actually mean I asked ChatGPT how many GPUs it required to train GPT-3,
Mm-hmm.
and it used to not give an answer, but this time it gave me an answer. It said uh, the GPT-3 model was trained on 3,072 GPUs, and it had 175 billion parameters. And that was that was 2020. It was released in 2020, so that means it was using probably Nvidia A100s,
A100s, yeah.
right? And so now GPT-4 is going to be the next one. I don't know how many. I don't know how many parameters it has, but it's more than 175 billion. I'm
Yeah.
guessing.
Yeah.
It's a couple, 2-3x that probably, but it's going to get trained on H100s, I think.
Yeah.
Or
Likely.
maybe it won't be ready in time. But whatever. Like somebody's going to train something on H100s, which are much, much, much more powerful than A100s. So just to put that in context, like what does an A100 cost? Probably $10,000 each. So $10,000 times $30 million times 3,072 is $30 million of just the compute, plus the rest of the cost of the server and the power. So that's a lot of money,
Yep.
right? But of
And
course,
and
it was done in the cloud, so it's not like they have to pay for all of that.
right.
We're going to need a lot of GPUs. That's
Yep.
or something to train all this.
Yeah. And the timing of this episode and the Nvidia didn't get to fit into our earnings preview from a few weeks ago, but they announced their earnings yesterday or 2 days ago. The stock popped because they guided to kind of a better year for data center, and I think on the back of this generative AI trend, where clearly the people are going to start shipping or buying H100s instead of A100s, and the whole system that ties NVIDIA solutions together puts them in a really good spot. I mean, I mentioned this, right? I think they have near 100% or something very close on training here for these foundational models and these transformers, not inference, just sort of the training side. But the lion's share is being done on NVIDIA's software. And Jensen used this number at their investor day last year, and he highlighted it again today, that just chips and systems, so infrastructure, components, is like a $300 billion TAM. Now, over time, yes, right, how long? But that's a monstrous upside. That's not even software. That's not services. That's just the chipset TAM, $300 billion. You know, NVIDIA is a 26, 28, $30 billion a year company, right? So to throw out a number that says, hey, look, 300 billion, and hey, right now we're the lion's share majority of these chips on training, maybe not forever, but that's a huge upside. And I think a lot of that's driving this multiple that they're trading at, which was 100 yesterday. I didn't look today, but now the largest in all semiconductor companies, because you know, they're really, really well positioned. But again, I keep coming back to this. They can only make so many GPUs. You know, it's not like they can all of a sudden ship whatever 30, 40 million, right? We're talking about, you know, 20, 30 million servers. I just wonder how much of this, like I said, outstrips compute capacity, because, and I agree with you, right? We're in an initial bubble, and this might last 2 years, I don't know, 3 years, I don't know how long, but we're in this bubble. But in that bubble is going to be very, very computationally complex. And so those are some bottlenecks I think we're up against. And it's not like you can immediately solve this with a coprocessor or some other AI accelerator. Like, you solve this on parallel compute and GPU. So I kind of, again, I'm sensitive to, we might see some bottlenecks. Like, how much is that going to hurt? Who can do what? And who has access to compute and who doesn't?
Yeah, so I think about it this way: is whatever size the GPU data center GPU market is, training is roughly sort of 10% of that, right? So it's probably $1 billion market today. I don't know. I'm just making up these numbers.
Sure.
But it's sort of 10, 20, it's about 10-ish percent, right? The big bulk of the opportunity is inference, and we can talk about that later. But
Right.
in training is incredibly computational intense. You need some real heavy irons to throw at it. And there's, you know, there is Nvidia doing training today, and then who else, right? Google has a version of TPU. It's like a subset of the current TPU
Right.
that they're going to use for training. But I'm pretty sure their Bard GPT clone or answer to GPT, that was done on Nvidia. I've heard that rumor. AWS has Trainium. But so far, that's only in version 1. Again, I'm pretty confident they're working on version 2, so they must be seeing something they like. But that's not training these big LLM, large language model GPT things yet. It's you know, it's a very, very first gen chip, and you know, and we certainly don't see AMD GPUs being used for this. So yeah, there is. You know, I think you're right. There will be bottlenecks. It's not a huge market. Like, his $3 billion figure is for all of everything.
Yep, all of it. Right.
So,
right.
but even still, 10% of that goes to training. That's still a $30 billion market, which, like you said, is, you know, their revenue today.
Yep.
So I think I think what'll be interesting from a commercial perspective, like, how much pain will everybody be willing to put up with before somebody's willing to try an alternative?
Right.
And it'll be very interesting to see how well NVIDIA can navigate this, because they're essentially 100% share that makes them a monopoly, and they're expensive, but I don't think anyone is accusing them of price gouging. They're pretty performative parts. They're not $100,000 per GPU. So do they continue to walk that line and just make it just expensive enough that they get good margins, really good margins, but not so expensive that somebody else is sort of given a way into the market?
Yep.
Because getting into the training market for anyone else is going to be really challenging. Like,
Yeah.
3-4 years ago, there was this big wave of all the big US VCs invested in. They picked their favorite AI accelerator, and almost all of those companies failed. Like, they
Yeah.
or failing now, or they got acquired pre-revenue. I mean, there's some good exits there, but there wasn't a lot of really competitive product coming out.
Yep.
And the ones that were sort of explicitly going after the training market got hit the hardest because there's some real software barriers to entry here that really only Nvidia can address, because it all comes down to CUDA.
Yep. Yeah,
So
and I think the big thing is, like you said, a lot of those accelerators. I mean, really, where a lot of them fell down was they couldn't run transformer architectures. They're fine for inference, they're fine to accelerate parts of that, but not really the training side. And I have heard of, AMD has some usage, but again, not nearly the same degree that Nvidia is. But you're right in terms of the size of the market, right? It's not all training, but training, the networking switches. I think that's what Jensen's $300 billion number is. But again, I think it shows how much growth and upside there is, or at least how much pressure this space will put on companies to grow and scale. Because it's interesting. I don't know how many of these kind of initial AI startup generative software platforms you're trying, but I'm on like 30 or so different trials that I'm on, or betas. And the funny thing is they have to launch these in limited capacity because they can't scale, right? They can't just let everybody in at one time. It's really expensive. It gets super slow and it just doesn't scale. Now, you're absolutely right. Like, not all of these are gonna stick, right? This is a boom bust cycle, which is fine. But I just find it interesting that not a single one is open. Like, you have to reserve your spot for all of them, just because, again, it's expensive and they just don't scale. And a lot of that's still on the inference side. It's not necessarily on, the model's been trained. They've put their wrapper around GPT or something. And this is just, they still have trouble scaling. So I think, again, it just shows how much pressure there is on the data center and the upside opportunity for growth when you're seeing these problems day one, and you sort of thought this shouldn't have problems scaling, but it is having problems scaling.
yeah, I think that's the thing, is it's the limited availability is all down to cost of inference, right? Which is, in theory, can be done. It doesn't have to be done on Nvidia. It can be done on lots of other things.
Yeah.
But everything's getting bottlenecked on that because it's pretty expensive, right? Dylan Patel did a piece, sort of, he did a couple pieces trying to guess the cost of it and how much it was going to cost for someone else to replicate. And it's some good math, but I actually think all this sort of scarcity right now is going to be a head fake for the industry, for the semis industry, because people are going to look at this and say, "Oh, look, ChatGPT is a real thing, LLMs are a real thing. Let's really go hard after this inference market because it's much bigger than the training market, and we can't get into training anyway. But let's go after the inference market because that's where the bottlenecks are." And I actually think in a cycle or two, the cost of inference is going to fall pretty dramatically. I think that's like, people are going to focus on that opportunity, and I think it's going to deflate fairly quickly. That's where the bubble will really burst, because I mean, it's just Moore's. We will still have Moore's law for this hype cycle, and the cost of inference is going to fall pretty dramatically. Plus, there is everybody and their brother or sister is going after some kind of inference chip, right? I mean, I see a lot of pitches, and I literally see one pitch a week for somebody has some new inference chip out there, and it's like, I don't think the market is big enough for that. Like, I think data center hyperscalers are mostly going to rely on their own silicon or Nvidia, a little bit of AMD thrown in, and then right. So then what you're really talking about is inference at the edge in kind of all kinds of random devices. And that feels to me like that market's going to go to the incumbents, right? Apple already has all
Sure.
kinds of
Sure.
inference in the iPhone.
Yep.
Qualcomm talks up their inference stuff.
Yep.
So I'm not quite sure where the market is for new companies here. As big as the opportunity, as exciting as it sounds right now, I'm a little bit hesitant about it all.
Yeah. I think I would agree with that. I mean, I think when you look at the inference opportunity, no doubt, even if you're traditional players, right? So Intel and AMD, and then eventually with Nvidia's CPU, like even by the incumbents coming in and solving those solutions, will bring those costs down. I don't know.
Right.
I don't know how much of an opportunity there's, like you said, for something else which might be an ARM or an FPGA or a RISC-V based architecture that's doing. I just don't. I agree with you. I don't know where those fit because again, you're exactly right. Amazon will bring it down with their costs. Google bring it down with TPU, probably their ARM accelerator. Microsoft will do something custom, I'm sure, at some point that's in this area. And so, what are you left with, right? It's kind of a moot opportunity.
Yeah, I actually think that like I'm conscious of the fact that I'm sounding pretty downbeat, and I don't mean to, but I think that everyone has to be very smart about which opportunities they go after, because I think we're going to encounter a case of Gervon's paradox here, where the price of inference will fall pretty radically, and then we'll start to see inference put in all kinds of other things, which maybe makes it more interesting. Like, you know, there's certainly inference going in all kinds of IoT devices, cameras,
Right.
right?
Right.
Remote controlled cars, industrial stuff. I think the industry's barely even thought about what we can do with AI inference in industrial machines, and there's probably a fair amount of utility there. But it's going to be a while before we start digging into that.
Yeah, I mean, you and I have talked about this one before, but even just looking at sort of what's going on, I guess you consider this edge, right? But in agriculture, especially with the tractor that John Deere keeps showing off, that's got like 5 different cameras, thousands of sensors that'll recognize a plant versus a weed. I mean, this is like completely unexplored territory where you're putting edge compute plus some cloud, right? That's going on in a vertical environment. You've got healthcare, you've got all these different smart cities, right? Areas where that makes a big difference. And that's a wide open field. One, just in terms of like, I think about this super interesting, just from like a hospital standpoint, right? Especially when we look at these models, because for a hospital to run, call it some form of a generative data application, they don't need it to be 170 billion, right? 300 billion endpoints. Like they just need data points that's theirs, right? Their models might be really small, but then they're using it for their research or their hospital's knowledge base. And so for them, they don't need to train this massive parameter model. They can use a small model, but still use that same approach and get value from it. Like legal companies are another one, right? I know there's like a handful of now legal verticals. One of them is named Harvey. I only remember that because of the Suits show. But theirs is, again, what if a legal company just trains it on their data? So now they have their resource, their archive, their their trials, their cases. It doesn't have to be that big, but that's still going to require that inference, that training, maybe some on-prem stuff. So it's interesting how this gets used in verticals. And then again, the impact that'll have on back-end systems, cloud providers, middleware, you name it.
So I think part of the difficulty in thinking through all this or analyzing all this is the fact that we're sort of all hung up on calling it AI when, really, if we just substitute the word AI for software, right?
Right.
There's a cool new software tool out there, right? And it just happens to be incredibly compute intense, but there's a cool new software, there's a cool new application. Let's figure out different ways to use it. And I think if you start to look at it from that framework where AI isn't some separate weird thing, it's just matrix multiplication at big scale, but just matrix multiplication. It doesn't have to mean the whole semiconductor industry has to shift. What we've just found is there's a whole new category of software that's going to run on it.
Mm.
And I think it's analogous to sort of office productivity suites, right? Office
Sure.
productivity tools, right? In the 1980s, that drove PCs, right? That was a big
Yep.
industry. I don't think
Yep.
it reshaped semiconductors. It certainly funded a lot of them, and I think we'll see something similar here too, where we have a new set of productivity tools that aren't necessarily going to change how we do compute directly, but are going to be a big driver for that. So
Yeah.
that's it. I'm just going to call it.
No.
I'm not going to call it software anymore. I'm not going to call it AI anymore. I'm just going to
Yeah.
call it it's more
Well,
compute.
it's true too. Like I had made this point a while back on Twitter where I said, if you really look at what the underlying use cases that people get excited about, it's really just workflow automation. Like it's just helping you do stuff faster, right? And so really it may not even be artificial intelligence, it's just artificial automation, right? It's just speeding up your tasks. And I even said this on Twitter yesterday, because the thing that got everybody excited about ChatGPT when I showed it to them for the first time was not that they were like, this is going to revolutionize how I search the web. They're like, man, this is going to help me speed up my day job tasks. Like, when this comes to Office, or when it comes to Workspace, or when it comes to Adobe, and people can just speed up their workflows, like that's where this gets really excited. But that goes back to your software point, right? This is just a new way to enhance and enable software productivity tools, workflow tools, that's going to let us get more done in a short amount of time. And yes, it takes a lot of compute, which is exciting, and there's a long growth area, but it's kind of another, I don't know what you want to say. I hate using the epoch term. It gets too used, but it's just another phase in development of software toward our goals of being more productive with computers as humans.
Yeah, yeah. I think that. I mean, I remember back to the days of MS DOS. I remember my friend Brad Turner his dad worked for an airline, and he had a PC in the early '80s, and he had a PC in the house. And one time we snuck down and we turned it on, and we thought we were being so naughty, and it was just like an MS DOS PC, and we got so bored so quickly. Just text
Yeah,
based, like it was we turned it off after 5 minutes. But then like he needed that for work, but not many people did. Not so long later, Windows came out and Office came out, and suddenly there was this huge growth of utility that anybody could use. You didn't have to learn how to do DOS-based commands, and so people went out and bought PCs. Had a good reason to go out and buy PCs. And I think that's something very analogous to what's happening here. Is we're adding another very powerful, useful set of productivity tools that the average person can use for certain things.
yep,
And but at the same time, I think part of the problem we always fall into is that term artificial intelligence. For a lot
right,
of people, that sounds much more exciting than it really is.
sure,
It's a big deal, but it's not like computers. Skynet is not arriving, right? HAL is
right,
not here yet.
right. Yeah, AGI is still a long way off, but no, I think that's the right perspective. But I'm curious though on this, because I've been sort of debating, like in the grand scheme of this history that you sort of just outlined, and you kind of look at from DOS to Windows 95 to mobile and touch. Like something in here feels like we're on the cusp of a new way to interact with computers. Just this whole either text or speech space. So like, would you say that we're kind of similar at a moment of man to human interface interactions as some of those fundamental ones, or is this more just an evolution of what we've had?
Yeah, something about this is sort of tickling something in my brain. I want to write it down. I haven't totally figured out how to articulate it yet, but I think this is not that. I don't think this is a fundamentally new way to interface with compute, which is what PCs were, which is what mobile was.
Right.
This is just something much more useful to do with those tools that already exist. And I think the semiconductor industry in particular is on the hunt for the next smartphone, the
Sure.
next PC.
Sure.
I don't think this will be that. This will be important, but it's going to be a little bit narrower. Uh, because I mean, I think AR, if it ever gets here, will be that sort of next interface. And I think those are epochal. That's the word for it, epochal.
Sure.
Which
Sure.
how we
Epoch.
interact how we do I/O, how do we interact input and output
Right.
with a device. This is this is more akin to a killer app.
Okay.
I think that's how I'm sort of thinking about it. Um, but because I've played around with a lot, especially with GPT and with Chat GPT, and it's I can see the utility in it. Um, it certainly is great for certain things, but it's still a little bit. I'm still typing into a
Yeah.
keyboard,
Right.
and it's not. It will be useful for certain things, but it's not going to really necessarily change big chunks of my life
Right.
yet.
Right. And I think the challenge with that, and honestly, like I mentioned, right, I've been trying these, dozens of different things. I keep coming back to ChatGPT as the most sticky of all of them. But even that, and this has some parallels, right? Just to Google in general, like it really depends on how good of a prompter you are to get the response. Like you do have to have very good or sometimes clever prompts, or it's just not that useful. And so that to me, while better than having to memorize a set of verbal commands, right, for voice assistants, is still a limitation in that, yes, there's more parameters, you can talk to it naturally, but it still has those limitations in the effectiveness that you get out of it in order for it to actually be still useful. That I still think we've still got to figure that out. Like people get it, but then you can have your power users, people who are better. Some software tries to make it generative and you're like, it's not even helpful in this scenario.
Mm.
So it's kind of like, oh, I've got this generative thing, I'm going to throw it on a new PowerPoint making software tool. And you try it and you're like, did not even come close. Like I can just make one of these faster by hand than you can using generative. But they're trying to capitalize on that hype cycle. Anyway, my point is that I agree with you. There's something there. Something's going to make us more productive. But these things in their early iterations still, like the hope of usefulness is there. I still haven't used it and been like, that's it. Like this is going to revolutionize my daily workflow.
I mean, I don't want to get too. I don't want to try too hard to evaluate ChatGPT because it's useful. But I'm not an expert in this, right? If I were really smart, I would go out and build a company based on it. Um,
Right.
and a lot of times, really powerful, important things like say the internet seem really trivial at first, and so I don't want to totally discount ChatGPT and say, oh, it's not going to completely change the world. I think you and I agree, though, it doesn't feel like it will, but it's still useful and has potential. And maybe it just shows
Right.
us what
Right.
maybe it's just the start of something.
Yep.
Regardless, it is clearly useful for at least a small set of applications that can help people in certain ways, and it will absolutely drive demand for semiconductors, which is
Yep.
something you and I can talk about with some degree of expertise. And so I think in that context, it is an important leg for the industry, get things moving again. Because for the last few years, we've all been a little bit stuck. What's the
Yeah.
next thing? Is it VR? Is it AR? Is it crypto? Whatever. Like,
Yep.
I think this is going to lead to some pretty solid growth, but at this point, it's still also a fairly narrow set of beneficiaries.
Yep. One of the things I've been thinking about too is and this comes back to the AI infrastructure kind of question. What kind of and this is a fresh question, I think, for us to kind of wrestle with and then come back to as a theme or tracking. But what types of progress benchmarks do you think we should be looking out from? Because I've thought about this as like, well, what if ChatGPT or some form of generative thing just inferences faster, right? It's just faster than it is. There's less latency, or that we can train X model of so many billion parameters in half the time. Like, I'm trying to think through what kind of measurements of progress that compute is advancing, the algorithms should we maybe look for? Because my guess is a lot of infrastructure companies will want to use those metrics, right? I draw less power. I can train these things at half the energy, or I can train 300 billion parameters in half the time, or you use it and the whole thing is instantaneous. Like, I'm just thinking through like progress benchmarks in compute and trying to wrap my brain around some stuff that we might watch out for.
Yeah, I think for training, the big one is time to train a big model, and it still takes a few weeks, even with 3072 GPUs behind it.
GPUs. Yeah.
Um, so certainly for training, yeah, time is a big deal. I don't think power is quite as important because it's not like 24-hour 365. It's fairly narrow window. Um, I I don't know. It's a good question. I don't know how much training is being done by all people at all times. It feels like it's much more start and stop. Like you're not many people are going to be always training models. Inference, I think latency and power are going to be the ones that matter the most. Right? Latency and power, and I think when it comes down to the chip too, it's going to be the amount of memory required to
Yeah,
run inference.
memory.
I think that's going to be the big. I think it's going to be a big sticking point.
Right. So on that point, you feel like some of these experiences that we'll have, like you as the end user will feel them be measurably faster or something like that. Like it'll feel more like instantaneous software than tying to a cloud application that's running algorithms.
I don't think so. I mean, there was a little bit of complaint about ChatGPT in its early days and how
Right.
long it took to scroll out, and like they fixed that. They reduced that time pretty sharply, and mostly what they just did is they put in a button that you could stop it in the middle,
Right.
um,
Right.
which is
Broke it up. Yeah.
I think all that people really wanted. Yeah, it could. I mean, it's like Google. I think it's different than Google, right? Because Google has the thing. It says how long the search took, and they've quantified that every whatever
Sure.
10 milliseconds reduces their monetization mechanisms. And I think,
Right.
but for us as a humans, that's that's not a totally understandable metric. And I think for some of these things, yeah, it'd definitely be better if it just instantly sort of spit out an answer. So latency is going to be a big one, and I think a lot of that's going to be tied to memory and bandwidth, on chip bandwidth.
Hmm. Yeah, and I wonder too. Do you have any read on how much? So both those things, right? So not necessarily CPU, but obviously GPU side. Um, how much of like a re-roll or rebuild of data center some of this is going to take? Like, is most of this just slot in parts, or are we talking about some parts of a data center just having to be functionally reconfigured?
That's a good one. I think the best data we have on this has to go back a few years to when Google launched TPU, right? Where they said specifically, they said having TPU, if search trends continue and voice search in particular gets to 5% of search,
Hmm.
then having TPU will allow us to reduce the number of data centers we need to build by 50%.
Hmm.
And so, absolutely, there's going to be a big capex hit here. I don't think that anyone has really thought through what it is going to require yet.
Yeah.
Right? I don't think Amazon's out there building a whole new data center just with
Sure.
GPUs for this yet. And I'm not sure we ever will need to get that. I think we're already seeing a growing mix of GPUs in the data center, and I think this
Yeah.
accelerates that.
Right.
And I think you probably just sort of fit that into your natural, your natural upgrade cycle. Every two,
That
3
makes
years, you sort of swap through all your parts in
right.
existing data centers.
Yeah. It's interesting too, because I don't know if you heard this. I don't think they still do it, but I had some friends who sold core connectivity bits to Facebook's data center, and I guess in its prime, which I think still goes back to a few years ago, right? But as Facebook was scaling, I guess they would just completely redo their data center. So take out all old parts, put in all new, like every few years, like every 2 to 3 years. They were just racking them out, putting in new ones. I thought that was fascinating. I don't think we have that, like you said, that same sort of problem where companies are going to have to do that in terms of data center builds out. But again, it comes back to how much of this core components or how many systems do they need to be converting to? Because again, we are talking about a lot of new applications requiring new compute, especially if we need new memory, new connectivity, new switches, opticals, etc. To speed these up, I would imagine some parts of those are, these racks are replaced by X and this section's replaced by Y.
So I think Facebook is important, but sort of from in the converse, because everybody held up Facebook as an example of like they clearly had a very different model, and I just know from having worked around them in the past, their approach to data center hardware is a little bit different than everyone else's. They are
Right.
much more likely to buy the cheapest component out there because
Right.
they're just assuming that's going to break and they'll swap it out. But everybody points to that as something different, which implies that no one else does that, right? I think
Right.
everyone else wants to run their server for 2.5 years and get it, past the point of full depreciation, fully utilize it, and then swap it out. And I think I haven't looked at the data recently, but I know for a long time, new build from the hyperscalers was a much larger, just dwarfs demand for replacement parts. Right? They're building, all the Super 7 are building a data center, a year roughly, probably more, and that construction was much greater than the replacement stuff. That demand.
Right.
I suspect it's still the same, but probably not quite as out of whack. And so then it's an interesting question though. If you're a product manager or a CEO at Google or Amazon, and you have to plan out like how much GPT do I need to power?
Yep.
Google's clearly been on I'm not going to call it AI, the matrix multiplication path for a long time. So it's probably built into their planning. It's hard. I think if I were in their shoes, I would have a hard time saying, "Oh, we got to scrap all our plans because of LLMs," right? And double the amount of GPUs we're going to buy. I don't think that's going to happen. I think most of these companies saw something like this happening and are sort of on a similar path already.
Yeah.
And I don't see why they would now say, "Oh, we got to like really, really double and triple down and get something new out."
Right. Yeah. I think that's right. Interesting. All right. Well, this will be a topic I think will frequent throughout the years as things evolve. You're off to MWC, so we'll do a recap of what you learned there in the world of semis at MWC when you're back.
Yeah. Next episode will be telecom wireless heavy.
Telecom, ORAN, VRANs, all of it. Okay.
Yep. Heavy stuff.
Great.
There.
Well,
cool.
Enjoy MWC. If people are there, reach out to Jay on Twitter, get emails, and we will talk next time.
Bye, everybody.